the problems that we face every day in our daily life that leads to the construction of lift. The problem number 1 is to lift the heavy things upwards. You cannot lift all the heavy items just by taking the stairs. Let's watch this video as an example of the situation.
Macam teringat lah. Hari tu, cikgu besar cakap, sekolah kita ni macam dah ada lift. Kat mana? Jom kita cari. Ni dia. Macam mana nak gunakan lift ni? Kan dia kot. Buat. Lift ni daripada tingkat 4. Jadi dia nak turun ke bawah. Macam mana lift ni boleh turun ke bawah? Tadi lift tu kat tingkat atas. Misteri lah. Wah, saya dah naik lift lah. Nak tahu tak macam mana cara lift ni berfungsi? Jom kita belajar.
The second problem is to enhance the understanding of Pascal law among the students at the school. As we all know, there is no lift in the school. So, how will the teachers are going to explain about the Pascal law to the students? Hence, we can use this hydraulic lift model.
First, I will explain about the Pascal law. Pascal law states that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. As you can see in the picture, if F is the magnitude of the normal force on the piston and A is the surface area of a piston, then the pressure P of the fluid at the level to which the device has been submerged as the ratio of the force to area is P equal to F over A. As you can see in this video is our hydraulic lift model. A hydraulic lift is a device for moving objects using force created by pressure on a liquid inside a cylinder that moves a piston upward. Incompressible liquid is pumped into the cylinder which forces the piston upward. When a valve opens to release the liquids, the piston lowers by the gravitational force. The principle for hydraulic lift is based on the Pascal law for generating force or motion, which states that pressure change on an incompressible liquid in a confined space is passed equally throughout the liquid in all directions. The concept of Pascal law and its application to hydraulics can be seen in our model, which is hydraulic lift model. A hydraulic system works by applying force at one point to an incompressible liquid which sends force to a second point. Based on our model, you can see that a small amount of force is applied to an incompressible liquid on the left to create a large amount of force on the right. And this is the total cost of materials that we use to build our hydraulic lift model.
Next, why the Pascal's law is very important. Firstly, it helps in the determination of pressure which can be exerted on the fluid in the piston so as to create enough force for lifting and moving an object. Secondly, the application of Pascal's law, which is the hydraulic systems, are capable of moving heavier loads as well as providing greater force than mechanical, electrical or pneumatic systems. The fluid power systems means it can easily cope with a large weight range without having to use gears, pulleys or heavy levers. Here are some types of hydraulic system. Firstly, hydraulic lift. It provides safe working condition in transporting of goods from one place to another. Secondly, hydraulic jack were highly advantageous in the automotive industry and are often used to lift cars above the ground level for repair and maintenance. Lastly, the hydraulic brake. The advantage of the system is that the pressure, which is set up by pressing pedal, is transmitted equally to all cylinders to make the braking effort equal on all wheels.
Thank you. That's all from us. We are Group 1A.